Okay, guys, welcome back to another lesson. Okay, angles and parallel lines. So, in the previous lesson, we talked about what is a parallel line, what is a skew line. Okay, we also talked about transversals, and we also started introducing corresponding alternate interior, alternate exterior, and consecutive interior angles, also known as same side interior angles. Same title for the same property. So today is, well, those angles, do they have anything special about them? And turns out, yeah, they do. Okay. Um, in class, we're actually going to start a lot of measuring to figure this out. But for you guys, you're going to miss that opportunity. But that's okay. You're still going to get the lesson though. So, for instance, alternate interior angles. If we measure them, are they the same or are they different? Corresponding angles. So let's say this guy up here, I'll make it a little bit bigger, and this guy down here. If I switch it up, are corresponding angles the same? Okay. Or are same side interior angles the same? Do they add up to something? Okay. So by measuring and a little bit of proof stuff, we can actually say that these do have special properties to them. And that's what we're going to discuss today. Okay? So here we go. So the first postulate we're going to talk about is corresponding angles. Okay? If two parallel lines are cut by a transversal, then the corresponding angles are congruent. Okay? What's very important here, okay? Talking to you guys out there, the lines have to be parallel for all of these. If the lines are not parallel, these properties are not true. Okay? So to determine if they are parallel, we have these arrows here. Okay? So please make sure that you're always looking for that. If the lines are not parallel, these guys are not congruent. Okay? So just be careful with that. All right? So example 1. The measurement of angle 5 is 72 degrees. I'm going to put that up here on my board. Find the following. So we're going to figure out what angle 1 is and angle 4. Okay, those guys are unknown. So I'm going to bring the board out here in the middle so you guys can see. All right, a little bit better. So let's take a look at angle 1. So angle 1 and angle 5 are corresponding, right? They're both left of the transversal and above the line. And we know corresponding angles are congruent. So this is also 72 degrees. And the reason is corresponding angles, angle 1 and angle 5. I'm going to put that little note there so I know. And please do that in your notes. They also want me to find angle 4. Now, look at angle 1 and angle 4. They are vertical angles, right? And we know vertical angles are congruent. So that too is going to be 72 degrees. So for a little note, I'm going to put that angle 4 and angle 1 are vertical. Don't mind this picture, that's for a different example in the future. Okay? And we're done. So there's the first couple measurements for us. The properties of angles that we talked about at the beginning of the year are going to come back into this as well. So we haven't talked about vertical angles in a while, but they're still here. We can't forget that stuff. Okay? So first problem done. Corresponding angles are congruent. Next, alternate interior and exterior angles. As long as the lines are parallel and they're being cut by a transversal, these angles are congruent. Okay, so far, we have corresponding, alternate interior, and alternate exterior. They're all congruent. They're going to have the same measure. Okay, and in fact, if you take a look at the previous example, we kind of showed that a little bit, didn't we? In a way, because corresponding are the same, we always have vertical angles, so alternate interior angles are always going to be congruent because corresponding are congruent. See how it kind of follows in line with what we talked about previously? Okay? And in fact, the proof for this kind of goes with it too. Maybe I'll upload a separate video on proving that. Okay? So we're going to have another example. And if you can't print out the PowerPoint slides, you can at least, like every example is going to use this picture, okay? Except this bottom part. So angle 6 is 70 degrees. So we want to find angle 3, angle 7, 2, 8, and 1. Okay? So I'm going to put this out in the middle so we can see it. Now, there are a lot of ways of figuring out what these angles are. So don't feel like if the method you chose wasn't what I did is incorrect, as long as you're following the right definitions and procedures. So let's look at angle 3. So 6 and 3, they're alternate interior, and we know that alternate interior angles are congruent. So that's 70 degrees. So I'm going to put 70 here. Okay. For a side note, you could say alternate interior. I'm going to abbreviate it as AI. Alternate interior to angle 6. Okay. I'm going to put that little note there so I know how I got to that conclusion. This will be very important when we start doing proofs. Okay, angle 7 is this guy here. Now notice, 3 and 7 are corresponding, which means they're the same measurement. So I could put 70 degrees here. Or 6 and 7 are vertical, which still makes that 70 degrees, right? So you see how there's two answers? Or not two answers, one answer, but two ways of getting to it. So it just depends. So I'm going to put here 70 degrees. I'm going to put C for corresponding to angle 3. Okay? Or I could have said vertical to angle 6. Okay, angle 2 is next. So angle 2 is up here. There's a lot of ways to do the angle 2, right? 3 is vertical to it, which makes it 70 degrees. That's one way of getting its measurement. 6 and 2 are corresponding, which gives it 70. Or 7 and 2, they're alternate exterior angles, right? Alternate means left and right. Exterior means they're outside of two lines. So we know alternate exterior angles are congruent. So I can pick any of those reasons to support that. So I'll put 70 degrees, and I'll put alternate exterior to angle 7. That's one thing I'm picking out. I could have said corresponding or vertical. Okay, but you just got to pick one reason. Okay, angle 8. Alrighty, so 8's here. Now notice something. I don't see a relationship right now currently. Do you guys? I don't either, right? So we get to come up with something different. So let's do this. How about, well, it doesn't really matter which way you put it. How about 7 and 8? Those angles are linear. Remember? They're angles that are on a line out to 180. If I were to turn this, it looks like this. Or to flip it. Okay. Linear adds it to 180, so they're supplementary. So what I could do is subtract that from 180, and I get 110 degrees. So that's 110 degrees. And I'm going to say the reason why it's supplementary to angle 7. Okay. Or you could say it's linear with angle 7. Okay. Last one is angle 1, which is up here. Now, same procedure. 1 and 2 are linear, so you add up to 180, supplementary. So I could subtract to get 110. Or angle 8 and angle 1 are alternate exterior. They're the same. So if that's 110, that's 110. So there's a lot of ways of getting to it. So I'll just say alternate exterior to angle 8. That's my reason. Okay? What do you think? Questions, concerns, dilemmas? Or are you just going to be quiet? Going to be quiet? Okay, you can be quiet. No problem. I know, cheesy commentary in the video. Hey, if you're going to watch it, might as well make it entertaining. Okay, so let's continue on. That was a fun problem. All right, now, consecutive interior. Once again, as long as the lines are parallel and a transversal cuts through it, consecutive interior are supplementary. Okay, you have to be careful with that. This is the only set of angles and that whole list that we learned that is not congruent. Okay? Let's go back to the previous example. So notice something. If this is 70, this is 110, because once again, 2 and 4 are linear, right? They add to 180. Now, same sine to your angles, which are these two guys, it's 110 and 70. Do they add up to 180? They are. So they must be supplementary. Okay? See how we can get to that conclusion based on the measurements and the other properties from the previous angles? I haven't done official proof yet of this to show you, but we can just see based on just some calculations and some measurements, we can get to that conclusion. Okay? So just be careful. An easy way to remember is that same side or consecutive, whichever name you use, are supplementary, the rest are congruent. Okay? I think that's an easy way to kind of keep that in your mind. So, there we go. Okay, so a new picture. It's going to be the one I drew down here. So angle 3 is 85 degrees. We got to figure out what angle 5 is, angle 8, and angle 7. And I know I'm going a little quick in the video, but you guys have the ability to pause the video so you can copy things down. Okay, so make sure you do that. Well, what are we thinking here? Well, let's look at angle 5, which is this guy. Now, 3 and 5 are same side interior angles, and we just learned that those guys are supplementary. They add up to 180. So if I subtract 85 from 180, I get 95 degrees. Okay? So that's what this guy is. And I'm going to put a little note here. SSI, same side interior, to angle 3. Always make sure when you're coming up with a measurement that you have proof as to why it's that measurement. Okay? Next, angle 8, which is out here. Okay, angle 8 is a vertical angle to angle 5. So it too would be 95 degrees because vertical angles are congruent. So I'll put that down. Vertical angle to angle 5. Okay? I'm abbreviating a lot just to save space, but you have the ability to write the full thing out. And then the last one, angle 7, which is over here. Okay? There's a lot of ways to see this one. You could say that 5 and 7 are linear. They add up to 180. So you can do a little subtraction. Or 3 and 7 are corresponding. They're both to the right and above the line. And we know corresponding angles are congruent. So it's 85 degrees. So I'm going to put corresponding, I'll abbreviate, to angle 3. Now once again, there's another way of getting to that answer, right? There's another way of getting to this answer. So when you're solving these and practicing these problems, don't feel like you're wrong if you got there differently than someone else. Okay? All right, so there's our properties. Everything's congruent except these guys, same side interior. They add up to 180. Okay? All right. So, one final theorem, and then we'll do some more examples. Perpendicular theorem. In a plane, if two lines are perpendicular to the same line, they are parallel. Okay, so what that means is, if line T is perpendicular to K, it's also perpendicular to N if it's intersecting. Okay? So if you have a 90-degree angle here, as long as these are parallel, that's corresponding, which is 90 as well, which means that they're perpendicular. Okay? So small theorem, but one that is important if you have to verify if there's a 90-degree angle there. Okay? So here's a couple of additional examples that we're going to do together. So for the first problem, we have to figure out what y and x are. Okay? So, well, to be honest, there's no straightforward answer to this guy. So what that tells me is that I have to come up with other measurements for other angles before I get to the one that I want. Okay? So looking at this one, right? And the lines are parallel. I'm not going to give you a problem that isn't like that for right now. These two angles right here that I put an arc are linear. They add to 180. So if I subtract 55 from 180, I get 125 degrees. So that's what x is. Now look at y and x. The relationship for those guys is they are alternate interior. So that means they're congruent. So if this is 125, this guy is also 125 degrees. Okay, and the problem's done. Not that bad. Like I said, if you know what these properties are, you can quickly find the measurements. Can you imagine measuring things like this all the time? It's going to take you, not a lot, but still, if you had to measure multiple angles like this, it could rack up a good amount of time. So just knowing those properties really comes in handy. Okay, the next one. Got to figure out what x is. Okay. Well, I don't think this was a bad one. Let's think of it this way. What's the relationship between this angle and this angle? Well, they're alternate exterior angles, and we know that those guys are congruent. So if this is 104, this is 104. So to figure out what x is, I would say x minus 10 is equal to 104 degrees. And I'm going to put alternate exterior. I'm abbreviating AE for that guy. Does that make sense? So because they're alternate exterior and they're the same measurement, I can set them equal to each other. So add 10 to the other side, x has to be 114 degrees, which works, right? 114 minus 10 is 104, which matches the other angle. Okay? All right, let's try another one. First, identify what the angle relationship is. So these two angles, they're going to be classified as alternate interior. Second, name the property. Okay, well, alternate interior angles are congruent. Third, write an equation for it. Okay, so 2x minus 15 equals x plus 55. They're congruent, they're the same. So I'm going to put it over here, alternate interior angles. That's why I'm allowed to do that. Next, solve it. So we'll get the x's together, which I'll do by subtraction. X minus 15 equals 55. Add 15 to isolate x. Okay, so x is going to be equal to 70 for that guy. Okay? And we can always check our answers, right? If it plugs 70 back in, it should equal out. And it will. Alrighty. Okay, so we got 2 more examples to go. So I'll tell you what, for this one right here, well, yeah, we'll do it. I was debating on it, but I don't want to make the video too long, but we'll do this one together. This one's a little bit different, so it's probably a good idea to see something that is different. Notice all the lines are parallel. Okay, so that's what those arrows indicate. This one has 2 arrows to indicate that only these guys are parallel. Okay, meaning these lines are not parallel to these lines, which is obvious because they're intersecting. Okay, so for this guy right here, I got to figure out measurements. These are alternate interior, so I could set them equal to each other. Well, you could probably figure out without setting an equation. If I divide both sides by 2, I get 20. So x is going to be 20 in this case. But here's what I'm going to do. I'm going to still put 40 degrees here so I know the full measurement because I need that for y and z. Okay, next step. What would z be? Well, these 2 angles are same side interior. The only angles that add up to 180. The rest are congruent. So if that's 40, this must be 140 degrees for me to add up to that 180. So let me put that down. Same side interior. Last one, these 2 angles are also same side interior, right? So if that's 140, this must be 40 for it to add up to 180. But, do you see the other way we can do this? If this is 40, this is 40 because they're also corresponding to each other. So that's another way to get to that conclusion. Okay? So once again, multiple pathways, which you're going to see a lot when we start doing proofs. Okay? All right, one more to go. One more. I know this video is kind of lengthy, and I apologize. Okay, so now what we're going to do is we're going to look at a shape that looks like this, and it's an interesting shape. Okay, grand finale. Okay, so here's what we're going to do. They tell us that these lines are parallel. Okay, that's going to help. What I want you to do is when you're looking at problems that have parallel lines, think of this picture all the time. Because this picture tells me what type of angles I got. Congruent or corresponding, alternate interior, exterior, same side interior. So here's what I'm going to do. I am going to extend these lines. And extend this with this guy. Notice it looks like this. Right? I got two transversals. And this looks just like the examples we did in the homework. So now, thinking about that, what could I say are these two guys? What do you think? Looks like to me, they're alternate interior angles. It's this and this, right? So this is our alternate interior. I could set them equal to each other. So 3x plus 20 equals x plus 50 because they're alternate interior. Once again, always make sure you have a reason as to why you're doing this. Okay, if you don't have a reason, well, I can't really support that equation. Solving for x, we'll subtract x from both sides. For my first step, subtract 20 to isolate x. Divide by 2. 15. So 15 will make both of those guys equal to each other. Okay? Wait, so far so good? Yeah. So now the next part. This is where it gets a little bit tricky. Okay, this is where you have to be careful. A lot of people might start saying, well, aren't these same side interior angles? And the answer is, well, what do you think? Are they parallel lines? Actually, let me go back to the problem. Sorry. Is AE parallel to BF? It is, right? And they use the symbol. Remember, that symbol means parallel. So I'm allowed to say this next part then. Okay. If they weren't parallel, I couldn't say these guys are same side interior. So because these guys are also parallel, these must be same side interior angles. So let's think about this. Same side interior angles are supplementary. So I know what x is. So I'm going to plug 15 into here, and I get what? 65? This is 65 degrees right here. Okay, something like that. So what I could do is I could say 2y minus 5 plus 65 equals 180 degrees because they're same side interior angles. Now the reason why I hesitate a little bit is because I want you to really, it's like an emphasis in a way. If these guys were not parallel, okay, then I really honestly couldn't say these are same side interior because I'm looking at this picture just rotated. Okay, so I'd have to figure a different way of finding that measurement. So it's always key to know, are these guys parallel? Okay, so solving this remainder, we get 2y, combined terms, plus 60 is 180. 2y equals, take the 60 over, 120. So y just becomes 60 when we're done dividing. All right? So there's one example where there's a geometric shape involved with some parallel lines. right. Whew. That was a long lesson. One final thing to note, okay? You could do the converse of these guys. Okay, we talked about that word before. The converse means you take the postulate that I was working with and you flip it, and the same is still true. Okay, so what does that mean? Well, let's go back to this example. Okay, let's say I don't know if these lines are parallel, but I know this is 50 degrees and this is 50 degrees. So the converse, when you hear that word, okay, means if corresponding angles, I'll put that down. So if corresponding angles are congruent, I'm abbreviating a lot, then the lines are parallel. Okay? So these measurements prove to me that these guys are parallel. This whole lesson, we did the reverse. Because they're parallel, these guys are congruent. Now, this last slide is saying, okay, the reverse is true as well. If these guys are congruent, then I know for sure my lines are parallel. If this was 48 degrees, then these guys are not parallel lines. Okay? So that's what it means by when it says the converse of these theorems and postulates and so forth. It's just the reverse direction of it. So you can actually prove by using these angle relationships if those lines are parallel or not. Okay? And that's it. Alrighty. So I'll post the homework and the assignments later on today, but if you have any questions, please let me know. As you can tell, it is very crucial that you know all these locations to these angles and the properties, because if you don't know that, you're not going to find those measurements at all. All right, so you just need to be careful, and please, please, please ask questions if you have them. All right, so that's it for today, guys. Have an awesome day, and I'll see you all in the next lesson. All right, take care.